Hi, Dr. Dan. This is our project two. This is our Weather V3, where we integrated our SHT40 sensor and VEC NL4040 sensor using our I2C protocol through the wired library. And here we have our local sensor display, and we'll go ahead and walk through this code. Um, so here we have just our structure to hold the SHT40 sensor data for temperature and humidity. And then here we just have a helper, and this just sends our command 0xFD to the SHT40 sensor at address 0x4040. And then we wait for the measurement to complete, and then we read 6 bytes. And then we return the data in a struct containing the calculated temperature and humidity values. And then below that, we have another helper, and this is just formatting the time. And then here we have our constructor for our local sensor display. So this just initializes our sensor readings and our internal timers. And then we also initialize the local sensor display. So this just clears the screen with a background color, and then it sets the initial timing for updates. And then here we have our reset update timer. So this just resets the internal timers and then forces the sensors to read. And then here we have our update function. So this just updates our sensor readings. So if 5 seconds have passed since the last update, then we read new data from the SHT40 sensor. And then the updates are stored temperature and humidity values if the change is significant. And then it refreshes the timestamp for the latest sensor update.
Okay, this is Michael Martinez, and I'm going to be going over the rest of this code. So this is the local sensor display, and this is drawing the Fahrenheit temperature on the screen. And then, Eric, if you could scroll down.
My bad.
No worries. And then here we're setting the cursor, and then we're floating the display temperature. And then next up on line 106, we have the humidity display. And then moving on, we are displaying the timestamp. And then here we're just kind of getting all the data in a visual format. And then we're drawing the FC toggle button. And then lastly, it's the draw back button. And that's kind of a way for the user to navigate throughout the screen. And then lastly, we have the check toggle button pressed function, which is just checking if the button was actually pressed to continue to navigate. And then we have the check back button is pressed, and that's just another helper method to see if that back button was pressed to, again, help with the navigation throughout the system.
My name is Marta, and I am going to go over the code that I worked on, and this is for our weather project. For our project two, we are continuing from our previous project and what we did on the weather. Also, I'm so sorry, I'm a little bit sick, so I'm talking a little slow. Also, the code, I don't know why, but it's marking these as red. And I don't know, I think it has something to do with the platform INI, but our code was able to work and display on my partner's LCD, but I'll go over the code. This code is mainly so what I worked on is on the main.cpp file. Mainly the code is similar. We used the starter code from what we used from the other project, project one, and then we just added stuff onto it, but I'll go over the whole code. So we have our imports here. To handle Wi-Fi connectivity, we have the I2C RWH file that was given to us. We're also calling our local sensor display. That's what we mainly worked on for this project. And yeah, we just have our imports. We have here our variables. Our variables, to just log into Wi-Fi and then API keys. We have timing variables to get tracks of like the last time update. We have application state, and we have default zip code and temperature units here. And also we have the NTP client setup for time synchronization, which we're providing UDP support for network communication, and we're using UDP client to fetch the current time from from our server, and we're updating it, with milliseconds, or 1 minute. So we have object installation for display. We have object installation for display and sensor management that is here with a bool statement that we've identified to have the weather display, the zip edit, and local sensor display. And we have need red raw, which is a flag to indicate when the screen needs to be refreshed, and we're keeping track on the weather LCD, when it's powered on. And we have some helper functions here. Here we have some helper functions that converts times into human readable strings. And it's calculating the hours, the minutes, and the seconds, and it's formatting it as a string for us, so it's very readable for us. And then we have a Wi-Fi connection function that is handling the Wi-Fi connectivity, and it connects to our IP address, and then it just displays the IP. We just had it for like easy debugging. And then here we have like our for VCNL 4040 proximity helper function here, that is reading and initializing the I2C and reads the proximity sensor data. It's also getting not only the proximity, but it's also getting the ambient data. And then we have some LCD control update functions here. It's mostly like displaying on the screen and stuff like that. These functions are, they're displaying what the sensor is reading, like the proximity and the ambient light reading. And it's mainly set to so that if the proximity value is exceeding 400 and the LCD is on, the LCD is put to sleep. And if the value is below 400 and the LCD is off, it wakes up. And then the ambient light value is mapped into brightness level using condition mapping. And then, the brightness is adjusted based on the range and applied to the LCD. I'm so sorry, I'm like a little sick, but I'm a little stuffy. So again, we're initializing the VCNL 4040 sensor. It's a function that we're using to initialize the proximity, the ambient light sensor, with specific values that we've inputted. And then we have our setup function. Let me go to our setup function here. Here in our setups, we have, serial and M5 initialization, I2C sensor setup, Wi-Fi and time, and we have some screen initialization and, data fetches here that we've initialized to fetch weather data and get last updates of times of marks. And then when we go to our main loop function, we can see like all this is the rest is our loop function, where it's updating the M5 and LCD controls. It's also where it's checking for the weather screen. If it's time for a weather update, it is drawing the weather screen if it's flagged. It listens for button press or toggle temperatures until switch to zip code edit or view local sensor data is inputted. We have zip edit screen, which displays the zip editing interface and handles touch input. we also have a local screen periodically, which periodically updates, and draws the local sensor and is displaying it every 5 seconds and checks for button presses and toggles to get data. And it's just like delaying here for, to manage the loop and it doesn't break. But yeah, overall, most of the code we've had this from the first project, and this was a very cool project that we did. And yeah, and I'm glad you enjoyed the demo. And yeah, that's it. Thank you so much and have a great day.